Hi, and welcome to today's webinar. Thanks so much for joining us live. I'm Catherine Stapleton, webinar specialist at AWWA. And before we get started, I just want to go over a few tips and tricks to enhance your virtual experience in ON24. Please close any programs not currently in use. This will free up processing and increase bandwidth, speeding things up and strengthening your connection to prevent crashes. While technology glitches can happen, note that most common webinar issues can be resolved by simply refreshing your browser. If you do encounter a problem, such as frozen screen or loss of audio, please refresh the page before attempting to troubleshoot. As you explore the attendee console, feel free to move things around and adjust to your preferred view. All of the windows and widgets in your browser are customizable. Just hover over a window to display the toolbar, allowing you to minimize or hide, resize, adjust volume, and turn on closed captioning. Let's take a look at your toolbar. From left to right, the first icon is Presenters. This will open up your media player. Here, you can adjust the volume and turn on closed captioning. The Slides icon will minimize or maximize the center window with a live view of the presentation slides. Submit a question to the panel will open the question pane. We'll hold a Q&A session after the presentations, but questions can be submitted at any time. By default, you'll find the question pane located directly underneath the slides. This presenter information icon will open up speaker biographies and contact information for today's panelists. The purple icon will take you to AWWA's Events and Education homepage. Here you can check out upcoming webinars and events. Here you can access the attendee chat. We encourage you to use this tool to interact and share information with your colleagues. You can also reach an AWWA representative in the attendee chat. They're going to be available to answer any technical or webinar-related questions. This paperclip icon opens up your additional resources. Here, you can download a PDF of today's presentation slides. Reactions will allow you to share emojis during the live webinar. This thumbs up icon will open up the webinar survey. The survey will also pop up as soon as the webinar concludes. Once you've met the attendance requirements, this ribbon icon will appear, allowing you to download your AWWA Certificate of Completion. I need to inform you that the mention of specific products, services, or opinions expressed in this webinar do not represent AWWA endorsement. AWWA does not endorse or approve products or services. With that, I'll hand things over to your moderator and panelists. Thanks so much for tuning in and enjoy the webinar.
Hi, everyone. Welcome to today's webinar. And my name is Tony Emenrud, and I am the channel manager at Astera. And today we're going to, I'm going to be moderating the session on leak detection ecosystem and how we can address leak detection from a traditional and a new technology standpoint. So today we have a great list of panelists here, as you can see. I'm going to go through each one of them real quickly. And first, I would like to identify Cynthia Baumann from the great city of Garland, Texas. She is the Director of Water Utilities Technology there. And then we have a counterpart for me at Astera, Patrick Day. He's our East Coast Sales Manager. And then we have a field perspective panelist, and that's Justin Godsey, and he's with Watts, part of Xylem, and where he does field delivery of leak services. And when we have Jack Canfield from FIDO, who is representing new technologies in the country, the U.S. country director for FIDO, and we have James Mosshart from from Guterman, who is the Western Sales Manager. So as you can see, we have a full perspective of leak detection, the whole ecosystem here on the call with us today. And each one of them are going to go through different aspects of leak detection. So the agenda today, this is what we would like to cover and hopefully you take away from, is first of all, that utility perspective. What are the challenges and opportunities for using innovation in water loss and leak detection? And we're going to integrate, and then how do you integrate like satellite technology, those new technologies and AI along with additional leak detection? Other applications of AI, how do we use AI in the whole water loss management? And using different types of technology in the field, AKA boots on the ground perspective, and how do they see the different technologies as they do that pinpointing technologies? So then bringing it all together is combining all of these to get increased efficiency and accuracy for utilities to manage their water loss. So we're going to start with Cynthia. Cynthia is going to kick us off with a perspective on Garland and what she did with Garland using different technologies. Take it away, Cynthia.
Thank you, Tony. Good afternoon, everyone. So for those of you not familiar with Garland, Texas, we're located in the Dallas-Fort Worth area. We're the 13th largest city in Texas, serving nearly 250,000 residents. We have a large manufacturing presence here in our city. And fun fact about Garland, we're known as the cowboy hat capital of Texas due to the number of hat manufacturers that are located here in our city. So what were some of our challenges? Back in 2020, we conducted a water loss audit because our non-revenue water had climbed up to over 21%. And the audit itself had identified several opportunities for us, including developing a proactive leak detection program. So as the technology director, I was particularly interested in the satellite leak detection study that was cited in this report. So Garland, we're not the largest utility in Texas. We don't have unlimited budgets, staff. We have to be very intentional about every technology investment we make. And that's why I think our story kind of resonates with that mid-size utility. We can't afford to chase technology just for technology's sake. Every investment we make in technology really has to solve a real operational problem and demonstrate value. So with over 1,000 miles of water pipe spread across 57 square miles in our city, rising non-revenue water, Garland had a clear operational need to reduce water loss while using our staff more efficiently and addressing our aging infrastructure. We needed a new approach. So we started a pilot project in 2021 with AWWA. The first scan that we did with them helped us identify 265 leaks in our city, 84% of which were non-surfacing. We conducted 2 more surveys, and within that first 18 months of our program, we were able to drop our non-revenue water 11 percentage points. So successful results enabled me to secure permanent funding for a leak detection program. And to date, over the last 5-year period, we have found nearly 1,000 leaks. You see 993 leaks in our system. Those leaks have been estimated to be about 2.4 billion gallons of leaking water that we found at an estimated savings of $7.3 million. So those results speak for themselves. The satellite survey really helped our actions in the field narrow down on what we needed to, where we needed to search for problems and what needed to be repaired. So we've been doing this for a few years now. I just really want to share kind of some lessons learned that we've had and illustrate one clear example that we've had using this technology. So Lessons learned. The first one, satellite technology doesn't replace traditional leak detection for us. It helps our field crews know where to look. Our crews still use traditional acoustical equipment to confirm and pinpoint the location of leaks. They're able to narrow that down based on the points of interest that we get from our scan. We also use leak correlators overnight in particularly difficult areas to pinpoint these leaks. Lesson 2, combining those AWWA POIs, our GIS, our field crews, investigations, boots on the ground, and also looking at our repair history, work orders. All of this leak detection has really turned into asset intelligence for us. We've used AWWA's master plan data with all of this information to feed into our annual CIP analysis as a variable to really help us prioritize those pipe replacement strategies when we're going to ask for those big dollars every year. Lesson 3, the biggest leaks weren't always the loudest or the most noticeable. They were really those invisible non-surfacing leaks. A little bit more on that in a minute. And then finally, results build trust. So I was able to really demonstrate results the first couple of years. That trust secured funding for that program, and the funding has really created this leak detection program. One thing I would add is that consistency in your program is really important as well. This isn't a one and done thing that you do a scan and miraculously find all your leaks and you're done. What we found, we kind of backed off a little bit from doing our investigations, and our non-revenue water crept back up. I mean, we have our utility is over 100 years old. So with all of that aging infrastructure, it comes to reason that this is going to be an ongoing effort. So to illustrate this, this particular picture that I have on the slide here, this represents a leak that really changed how we think about proactive leak detection. There was no visible water on the surface, no flooded street, nothing a customer would see to call and report to us. There was a scan that we did in September of last year. We had boots on the ground identify this as a leak in November of last year. And our field crews were able to finally make repairs in February of this year. So conservative estimates put this leak at about 286 million gallons of water, or $1.3 million of treated drinking water. So to put that in perspective, for the past week in the entire city of Garland, during what's been the hottest week of the year so far, that is the equivalent amount of water that we've used over the last 6 to 7 days here in Garland. So in this lake, you see non-surfacing, they had to dig down. And when they further investigated and repaired this was a 6-inch cast iron pipe. So not only was it leaking in the ground, but it was also discovered that it was infiltrating into our sewer system. This is information that we also confirmed by correlating flow data in our smart cover system on our sewer system. We can see the increase in the flows that then decreased when the repairs were made in February. So we paid for the treated water, and then we paid to treat it again at our wastewater treatment plant. So that one repair completely changes the conversation about the value of proactive leak detection. The technology didn't replace our crews. It really gave them the intelligence to look in the right place at the right time and find problems that we otherwise could not see. And so with that, I'm going to turn it over to Patrick with AWWA to talk some more about the technology.
Cynthia, thank you so much. And hello to everybody. Appreciate you joining. When we talk about solutions to help in our fight against non-revenue water, particularly real losses as we're addressing here. I like to consider two camps. One camp, pre-location, as part of that first step in the process of leak detection. And then secondarily would be the pinpointing technologies. And there's few solutions that can do it all. Jack may present here through FIDO the ability to bridge the gap, but at the end of the day, I am convinced that across those two camps, pre-locate, big picture versus pinpointing, X marks the spot, dig here for the repair, is going to require multiple tools in your toolbox. And it's not necessarily that these solutions compete with one another. It's more about their ability to layer on one another, complement one another, and then ultimately confirm the findings before you do send a crew out to start digging. So, limiting the dry holes, and that confirmation rate will escalate if, again, those right tools are in place. So with that said, let's talk briefly just to get everybody familiar with satellite leak detection, because the first question that often comes up is, say what? You can actually detect leaks from space. And this technology has an interesting origin story. We found water on Mars, and we're successful in doing so. And like any successful aerospace or NASA-sponsored program, they're going to want to see how can that be commercialized? How can we benefit back here on Earth from technologies that have proven successful in that environment? And that's what's happened. So over the last 10 years, Astera has gotten really good at further developing not only the solution as far as the hardware that is satellite mounted, but really the algorithms at play that we use to distinguish groundwater from salt water, from potable water, from wastewater, and with high confidence to be able to give you what we call a point of interest, right? A highly confident detection of potable water outside of the pipe. And from that, we do it through these three components critical to our solution. The view, of course, is the view from space. Now, I said that we can be considered a big picture solution. We are possibly your step one to be able to assess your entire system with one scan to be able to see where detection of potable water or wastewater outside the pipe is found. And my analogy is, as we often use, is the old needle in the haystack. Well, I'll be the first to say that we cannot find the needle in the haystack, not from 400 miles above the earth. But what we really do a good job of is to identify in that hayfield, which is analogous to your system, which haystacks you need to send other tools and other solutions to find those needles. And so it's, again, the breakdown from big picture, pre-location, and then passing the baton to other technologies that can go in, confirm, pinpoint, and then X marks the spot, dig it and repair it. Because as all of you know, none of us win unless repairs are made. All the money that we say you're going to save, all those thousands and millions of gallons of water that we say you're going to save are not realized until those repairs are made. So that's the view from space. The sensor, again, there's only a handful of satellites that carry the commercial capabilities for us to see water subsurface. And that is conducted through synthetic aperture radar. That's the SAR acronym you see here. And we're utilizing L-band in radar. And from a commercial perspective, it's about as low as you can go on the frequency range for satellite technology, for radar technology. It's just above where most of you are operating AMR or AMI systems. And what it allows us to do is to present a very long wavelength. And with that long wavelength, we're able to penetrate not only weather, cloud cover, but down on the surface, cutting through vegetation, cutting through asphalt, being able to penetrate through concrete within reason, and other obstacles that other satellite technologies simply can't do. And once it's there, then we switch into really the core of our proprietary algorithms, and that is the analysis of the significant amount of data that is brought back to the satellite in that echo. We're using polarimetric satellites. So again, they are rotating North Pole, South Pole somewhat. And in doing so, they're able to present microwave pulses that penetrate subsurface and look for specific water signatures. And that is how we're able to type the water that we're seeing subsurface. So we don't necessarily see pipes. We don't see any other assets. We are looking exclusively for water in soil, whether it's pooling, whether it's channeling, and we can do that in very low concentrations. We have been verified down to 0.2 GPM. So again, we can see that water from space. We're able to detect what type it is by the algorithms that we're using to scrub the data, and then we're turning that back over as a point of interest for further analysis. And again, that's where the baton is passed to another technology. Most of the time, that's going to be a qualified, competent ground crew that's got state-of-the-art equipment, today's version of the old listening stick and the ground microphone, and they're able to investigate those points of interest and confirm for X marks the spot dig here. At the end of the day, what we're bringing to this kind of big picture view is incredible efficiency for any utility that again wants to start with our technology and then complement it with other technologies that can get down to the pinpoint phase of this process. And we have been very successful over 600 plus projects of being able to narrow the focus. And in this example you see on the slides here, from taking 500 miles of total pipe in the system and creating a mobilization plan to assess and investigate only 50 miles of that. So again, 10 to 15% is what we're bringing from an efficiency perspective, because we know that time, your again, staff, and the ability to get out and investigate is incredibly important, and you've got to make the most of those limited resources. And then of course, following that again comes back down to the repair. So making sure that we're able to close the loop from detection to confirmation to repair. And then of course, from Astera's perspective, we really need all of that circle to be fully closed. We need that feedback in our system because our AI gets smarter with every project based on that feedback. And with that, Jack, I will pass the baton to you.
Thank you so much. I appreciate the introduction. And so welcome, everybody. Good day. My name is Jack Canfield. I'm the USA Country Director for FIDO. Today, I'd like to discuss how advances in technology are changing the way water utilities detect leaks and reduce water loss. The FIDO solution. Water is one of the most valuable resources, yet a significant amount of treated water never reaches customers. Around the world, aging infrastructure, hidden pipe failures, and difficult to access networks contribute to water loss. Utilities have long invested in leak detection programs, but finding leaks underground can be challenging because they are often invisible from the surface and may go unnoticed for months or sometimes even years. Fortunately, technology is providing new tools to help us better understand and manage water distribution systems. The evolution of leak detection. Historically, leak detection was a highly manual process. Technicians would use listening sticks, ground microphones, and correlators to listen for sounds created by water escaping from pipes. These traditional methods remain effective and are still widely used today. However, they depend heavily on operator experience and require significant time in the field. Over the last decade, advances in sensors, telecommunications, cloud computing, and data analytics have transformed the possibilities for leak detection. Instead of relying solely on periodic inspections, utilities can now collect and analyze information continuously. This shift allows organizations to move from a reactive approach, where leaks are found after significant water loss has occurred, to a proactive approach focused on early identification and intervention. the role of smart sensors. One important development has been the introduction of acoustic sensors, such as the FIDO sensor shown here. These devices are designed to detect vibrations and sounds associated with water escaping from pipes. Every leak creates a unique acoustic signature. By placing sensors throughout a network, utilities can gather much more information that would be possible through manual inspections alone. The advantage is that monitoring can occur continuously, helping identify issues that might otherwise be missed between scheduled surveys. Connecting infrastructure through the Internet of Things. Another major advancement is the use of Internet of Things, or IoT. IoT technology allows field devices and sensors to communicate automatically with centralized systems. In this example, the IoT relay serves as the communication link between the sensor network and cloud-based platforms. This connectivity enables utilities to receive data from multiple locations across entire distribution systems, rather than collecting information manually and reviewing it later. Operators can access network conditions in near real time. As water systems become increasingly connected, the amount of available data continues to grow, creating new opportunities for analysis and decision making. So combining traditional expertise with digital tools is really the key here. An important lesson in many industries is that technology works best when it complements human expertise rather than replacing it. Mobile applications such as the FIDO Smart app provide field personnel with maps, sensor information, and investigation results directly on their devices. This helps technicians prioritize inspections and focus their efforts where the likelihood of a leak is highest. However, experienced operators remain essential, and I want to make sure we focus on that. Experienced operators remain essential. They understand local infrastructure, operating conditions, and environmental factors that technology alone may not fully capture. The most effective leak management programs combine traditional field knowledge with modern digital tools. Artificial intelligence and the future of leak detection. One of the most exciting developments is the use now of artificial intelligence. AI systems can process enormous amounts of acoustic and operational data, and they identify patterns that might be difficult or impossible for humans to detect consistently. Machine learning algorithms can be trained to distinguish normal network sounds from those associated with leaks. As these systems analyze more data, they can improve their ability to identify potential leak locations and reduce false alarms. Platforms such as the FIDO Hub use AI, the cloud computing to transform raw sensor readings into actionable information. Rather than simply presenting data, these systems help utilities understand where attention is needed and which issues may require further investigation. So in conclusion, leak detection has evolved from a largely manual activity into a technology-enabled discipline that combines sensors, Internet of Things connectivity, mobile applications, cloud platforms, and artificial intelligence. The key takeaway is not one technology alone solves the challenge of water loss, as described earlier. Instead, success comes from integrating multiple tools and combining them with the expertise of utility professionals. As water systems face increasing pressures from aging infrastructures, population growth, and resource conservation goals, these technological advancements will play an increasingly important role in helping utilities protect water resources, improve operational efficiency, and support long-term sustainability. And with that, I'd like to thank all of you for your attention and your participation in this webinar. And for that, I will go ahead and pass it over to our next presenter. Thank you again.
Hi, thanks, Jack. My name is Justin Gotze. I'm with Walks Water Services in Xylem. So I wanted to kind of build on what Patrick was talking about with bridging the gap between AI and the more traditional methods that we typically see in the field. So our first bullet point here talks about blending technologies for stronger results. So how do we begin building a proactive program while our utility partner may still be in the reactive stage? So What we encourage our partners to do is identify individual system needs to help create a custom approach to non-revenue water loss. What we like to see is maybe one of these newer technologies, an AI platform implemented, and then follow it up with those traditional methods to help pinpoint and mark the leak. So WOX, we like to step in and we like to help our utility partners with the data handoff portion from the AI technologies to the utility. So what we like to see is to have an opportunity to help our utility partners get from point of interest to excavation here. Our second bullet point talks about the application to efficiency and effectiveness in the field. So we want to make sure that we're applying the correct practices to deliver actionable results. It kind of goes back to that old saying of using the right tool for the right job. One thing that the AI platforms and the newer technologies do is they give you quicker identification of points of interest, maybe through the SAR technologies with Astera or the continuous monitoring with FIDO. And that leads us to faster field results that the crews can then go and follow up on. And it kind of increases the speed at which those traditional methods can be effective. Of course, lower non-revenue water loss, it directly translates to lower strain on the distribution system and greater insight into overall system health. Our third bullet point here talks about a case study out of the Southwest. So we have one utility partner that partnered with both Astera and WOX Water. Through Astera and through the Astera technologies, they located approximately 1,500 points of interest. An initial pass-through came up with 213 verified leaks by a third party and by the utility, the in-house personnel there. They then kind of used a blended pass-through with WOX Water Services where we identified an additional 1,838 leaks. It's an overall savings for this utility that already has low water loss in general, but an overall total of over 2,000 leaks located. It translates to over 511 conservative gallons per minute, which equates to over 268 million gallons per year of water recovered for this utility. So we can really see how implementing a blended approach can really drive strong results for our utility partners. The last bullet point here talks about asset management through Project Tracker. So I can't stress the importance enough of a successful asset management program. With WOX and with Xylem, we have what's called Project Tracker. It is a living, breathing asset management tool. Through Project Tracker, WOX Water has comprehensively surveyed more than 50,000 miles of pipeline. With our leak detection projects, we've touched and collected information on over 3 million assets. Through our valve and our hydrant maintenance program, we've collected over 2.5 million assets in the process, locating over 20,000 leaks for 300 plus utility partners across the US and parts of Canada. We've helped our utility partners recover over 47,000 gallons per minute. With Project Tracker, the beauty of having an asset management tool like this is it not only gives you the location of the assets, but it also provides information on assets that may have defects or discrepancies, maybe a location error. It helps to keep the GIS information updated in the event of an emergency for the utility. They can pull this information up and they can have a quicker response time. They're real-time results and they help reduce leak runtime. It leads to increased savings and decreases the likelihood of catastrophic failure. Lastly, I want to end with maintaining a good water stewardship program should include technologies that have the greatest positive impact on the system and the environment. A good water stewardship program should be agnostic of brands and specific technologies, but instead step back and take a broader view of what's the most positive impact technology that we can implement into our system. Of course, if you find the leaks, you'll find the revenue. So a good water loss program can certainly pay for itself and help to fund future projects. I see that Cynthia's already doing that in Garland, and those types of results tend to speak for themselves. So with that, I will turn it over to James Mosshart with Guterman. Thank you.
Thanks, Justin. Yeah, so James with Guterman, originally Cam Kai's in my office was supposed to be here. He had a family thing, so asked me to step in for him. I do notice a lot of familiar names on the list, so hello. So with Guterman, just to coincide with what everyone has been talking about, just having a program in general, multifaceted, more tools for the toolbox setup, you're going to get a lot more results, proactive versus reactive. So the way I've always looked at it when it comes to acoustic leak detection and reporting, I would say there's 3 steps. And it doesn't matter where you are in the world, if you follow these 3 steps, you're going to get the results you're looking for. So survey, correlate, pinpoint. Survey could be with the satellite, it could be with loggers, it could be manually, it could be several different ways. Then with the correlation, now you're getting even closer. And then obviously pinpointing, boots on the ground, getting out there and putting an X on the ground. The way I've always explained it is a 5-foot hole versus a 50-foot hole, because we've all been there where, you trench up the entire world trying to find where this water's coming from. So, and with, everyone had already previously mentioned manpower issues, things of that, to that effect. You're looking at, you need to do more with less. So yes, with any kind of technology that's out there, there is that initial sticker shock, but I think what we've seen already, like with Cynthia and Garland and, the examples that Justin had laid out, it pays for itself almost immediately. So that's always something you need to keep in mind. Now, where we are a little different with what we can offer as an added benefit is our loggers are on your system. They're on the valves. They're monitoring. They're letting you know. They're correlating. They're reporting in the morning and telling you, hey, why don't you start here? So you have the satellites and FIDO and so forth saying, hey, go into this general area. Now we're really getting real specific with correlation to the point where you can almost send out a field tech with a ground microphone to verify what you're coming up with. So I always said with the 3 steps, survey gets you on the street, a correlator gets you in the ballpark, and a ground mic puts you in the seat. So very fast, getting you where you need to be. With our technology, again, as discussed previously here with AI, it's machine learning. It's learning more and more. It's giving you more and more of an accurate result. It knows to eliminate electrical hum and other kind of issues that you might run into. And giving you a real focus on where to go right off the bat instead of chasing false positives or, certain anomalies that are in the system. I'm not saying that doesn't happen. It definitely does. But this is, with the AI technology that we're implementing, it definitely is getting us a much more accurate result. So, again, everything is just more tools for the toolbox. Whatever system you have, I tell customers all the time, if you don't have any kind of leak detection equipment, I don't care what it is, get something, start somewhere. And with enough technology and enough of those tools, you can do more with less. One person can keep an eye on an entire system, depending upon the size, obviously, instead of having to have an army of people out there. So again, all these tools that you're seeing today are definitely something you need. Get something is I think if you want to take anything away from what I have to say today, get something. Start somewhere. Any of these technologies will pay for themselves in the long run, and you will get the results. So that's pretty much it on my end. So if you want to ask questions away and take it, give it back over to the moderator here, we can do that. So thank you very much for hearing me out.
Yeah, thanks, James. I appreciate that. Thanks to all of our panelists today. We have, like I said earlier, a great set of panelists with us today. And if that doesn't show a one water for AWWA, what does when we bring all of us together and talk about leak detection? So thanks to all of the panelists today. So just in conclusion, effective leak detection, I think what you heard today was effective leak detection is not a single technology. It's really about making a comprehensive plan for your water loss and your non-revenue water. It's an end-to-end strategy. And as Cynthia mentioned, that it's also not a one-time strategy. It's not a one and done. It's an ongoing process. So utilities can achieve a higher impact with traditional leak detection methods when they're integrating things together, bringing satellites, bringing AI together to really go after that water loss program or end-to-end strategy. It helps make things smarter, more efficient, and more cost-effective. And that's definitely what utilities need today. So a proactive system-wide approach reduces real water loss, improves operational efficiency, and helps extend the external life of that infrastructure. And those are all things that are very, very valuable for utilities. So one final thought before we go to some Q&A here. We have a ton of questions in here. I'm going to try to lump some together and find some efficiencies there and then address some of them, but we'll address them offline too. So one final thought before we go, the future of water loss management is not choosing between traditional or new technologies. It's really about blending them together and leveraging both, which is right for that particular utility. Again, faster, more efficient leak detection is really what we're aiming for here, to bring this whole conversation together to demonstrate how they can work together. So now I'm going to do one more slide here. Here's all of our contact information. If we don't address your question as we move into the Q&A here, jot down, grab screenshot, take a screenshot of these contacts. Feel free to reach out to me. I can get you connected to anybody else here at Astera, and also beyond. So we are here to answer your questions. So let's go to that Q&A. And let's start with I'm going to start with a couple of bigger, broader questions that came up. And this one's going to be both for Cynthia and Patrick. Cynthia, we had a lot of questions regarding the pipe depth for Garland. And so I want you to address Garland specifically, but Patrick, I'd also like you to address pipe depth in general for satellite and just in general leak detection, because that does matter. So if we could start with Garland and then move to Patrick and do it from a general sense, that would be great.
Yeah, so, and I have gone through the chat and sent some individual questions to people or answers to people for several that look like they were addressed to me. And okay. I'm happy to talk more offline, but for us, we average about 5 to 8 feet depth for our water lines here.
Patrick, would you like to address it just from a general satellite perspective, and how deep can we look at pipes and identify points of interest?
I will, Tony. Thank you. It does run in line with what Cynthia just said. So I am based in Metro Atlanta. And of course, we are blessed with incredibly tight red clay soil structure. And we are also experiencing kind of that 8 feet to 10 feet of penetration and assessment of water in soil at that level, where we get into more rocky or more, let's just say more open structure soils. And that can increase to 10 to 15 feet. And then of course, overseas, we've got projects in the Middle East that are 20 feet, maybe plus in depth. So it really does, depend on that soil structure that's presented. But at the end of the day, I'd say, that 10 feet, 8 to 10 feet mark really holds up well.
Great. Thanks both Cynthia and Patrick. And I'm going to keep you guys here actually, because there's another kind of set of questions. is one's more specific to Cynthia, and that's your project cost. But then there's kind of a general question out there about how much does it cost to do a satellite leak detection program. So Cynthia, I don't know if you want to talk about the Garland budget for the program that you're doing, and then Patrick, again, if you could come back on and address just in general, kind of give people a ballpark of what they should be thinking about.
Yeah, I mean, I'd prefer to discuss that offline with people individually, and not, you know, I think I mean, I couldn't even tell you, there's different things that are built into that program. So we do 1 to 2 scans a year, which was also a question from somebody, depending on how we're making it through the POIs. And then there's the costs of the field crews, the, you know, repairs, the equipment that they're using, that sort of thing. So it kind of varies from year to year. But yeah, I'd be happy to talk more offline with somebody about that.
Okay, no problem, Cynthia. And then Patrick, just from a high level, what kinds of things, Cynthia's mentioned them already, but what kind of things influence the price of a project?
Look, certainly everything we engage is unique to the utility. So our pricing structure takes into account total area. And even though, you know, I mentioned we are big picture because we can see the entire system from space, some larger systems, particularly if they run east to west, which is counter to the orientation of the satellites that we utilize in orbit, that might require 2 passes or 3 passes. So we call that the image count. So the image count, the total linear miles of pipe that will be analyzed, also is a factor. And then to Cynthia's comment around what is the scan frequency? You know, are we going to be scanning quarterly or twice a year, annually? All that gets baked into proposals.
Okay, thanks, Patrick and Cynthia. Patrick, I'm going to keep you on the line too, because there's a lot of questions regarding how do we identify different types of water, and how does the satellite identify groundwater versus the different types of stormwater, things like that. Can you speak to how, and then can you just speak to how we identify and create those points of interest, if you will?
I can, Tony. And thank you. I appreciate the question, because I did not really take it to that extent. So our algorithms have been trained to look at specific water signatures, and what we are detecting is the electrical properties of water in soil. And primarily that is the conductivity, and more easily to isolate is the dielectric coefficient or the dielectric constant. Now again, between distilled water or potable treated water or wastewater or salt water or anything in between, they vary very slightly in those properties, but the data that we are able to capture from these polarimetric scans allows us to analyze and separate them out. And it really is helpful because we are operating in that 1 to 2 gigahertz frequency with our microwave pulse. And that allows those signatures to separate even more so, if that makes sense. So that's how we do it. It's electrical properties of water in soil. Now, we cannot see through standing bodies of water. That scenario basically looks like a mirror from space, and our microwave pulses will bounce off. So we can't see through creeks to see that, you know, that large PVC pipe that's run under the creek bed. Tidal marshes, again, if it's low tide and the pipe's exposed, then great. If it's not, we're going to have difficulty. So we can't see through standing bodies of water. That's another just thing to know. Did that answer?
Yeah, thank you. Thanks, Patrick. I'm just trying to scan through some of the other questions here. And you know what, I'm gonna throw this one out there. There's a couple similar questions about unauthorized service connections. And I'm going to see if anyone wants to address that, because I don't think it's specific to one of the single technologies. But is there anybody that wants to? There's a couple of different questions at the end user level, unauthorized leak detection. Does anybody want to address that?
Would be happy to address it if you like.
Go ahead.
So unauthorized leaks, generally what we like to say is that, you know, people are tapping into hydrants, people are tapping into, you know, sources of water, and because it's not metered and they don't have to pay for it. So there are ways, in fact, a lot of the technologies that you've seen today have what's called a consumption profiling ability. And what that does is allows for sensors to listen certain specific times during the day. If you wanted to say put it out into the area for like on a Wednesday and let it run through the weekend, you could then diagnose where these particular hydrants or water thefts might be occurring by understanding that there is no fire in the area, there is no reason to use water in that area, and therefore you're hearing it anyways. And at that point in time, you can then you know, do further research on it and work with your local police department to actually survey the area and actually catch some of these thieves in action. And we actually have had, and the reason why I wanted to have that conversation about that is we actually have done this in both the Texas areas and in the Washington State areas. Hopefully that answered the question.
All right, thank you. So I have another one here, Patrick, I'll bring you back on, and it's one of the questions is how large of an area can be scanned with the satellite? There's a lot of satellite questions in here. So
yeah, it depends on the satellite that's utilized, but roughly 1,200 to 1,400 square miles.
Okay.
And again, based on polar orbit, the frame is more of a vertically oriented rectangle. So if your system runs more north-south, high likelihood that, you know, one image will offer coverage, complete coverage.
Okay. I think we've covered, there's some very, very specific ones in here that I think we can just address individually. Here's one. If you already have an assessment management program, can the Xylem date feed in with the API? I think that's very specific too, but Justin, you want to address that?
Yeah, absolutely. So with Project Tracker, and I'm not a GIS analyst, I'm not on the analytics team. That would be definitely a question more tailored for them. I mean, you can always send me an email and I can get you in touch to answer your question a little bit better if I can't do it justice here. But so with our field crews, what we like to do is establish an open line of communication. As we're collecting information in the field, it feeds into Project Tracker, and then those deliverables are delivered back to our clients on whatever schedule kind of works best with the client. It's so variable. Some clients like the deliverables every week, some like them every month, some like them just as, you know, at the end of the project. But the real-time results go into Project Tracker. We have an open line of communication to specifically address leak reports. On my slide, it had a nice little picture of what our leak report looked like so that we can get that to our utility partner. They can print that PDF off and give it to their field crews for repair. Like the defective assets that we find, maybe there's a valve lid missing or a hydrant that's been sheared off, or maybe an asset discrepancy. You know, the hydrant said it's on the northwest corner, but it's actually on the southeast corner of the intersection. Maybe it was moved previously. Those kinds of things are delivered back to our clients through the deliverable mechanism. Our analysts do a really good job of accepting a wide range of GIS data. They can do geodatabase, KML, you know, batch geo, all that stuff, and they can also turn around and deliver it back to our clients in whatever format works for them. So I'm hoping that answers your question. But yeah, if there's anything else that I can help with, you know, feel free to reach out personally.
Okay. I have one more here for Patrick, and this is a common question is, where did it go? scanning around where there's already, where it's a high water table level, whether it's around a lake or just like Florida, things like that, Patrick. There's several questions that scanning a proximity of large bodies of water is a question here. There's a question about, another question about high water table levels. Do you want to address that?
I'll address it to just broad brush say that we do run into it. Particularly, we've had really good results in Florida. High, obviously, water table there. If the water table is below the source of the leak and our sensing is able to get to that potable water or that wastewater outside the pipe first, then it will be fully detected. If the water table has risen to a point to mask it or cover it, then that does become an issue. So we can certainly work within proximity to that water table, but we need to have a leak exposed above it.
Okay, thank you, Patrick.
And sometimes we are blessed that leaks leak upward, right? They want to evaporate. So
perfect. Sounds good. Thank you again to all of our wonderful panelists that were on the call today. Hopefully, and thank you for joining us this afternoon or morning or evening, whatever time zone you might be in. Hope you got something from it. And before you go, there's a download of the certificate and a survey that is going to come to you. So thanks everybody. If there's any specific questions, Q&A questions, like I said earlier, we'll address those. We'll address those individually because there were some pretty specific ones. But that concludes this presentation, this webinar. And again, thank you.